Anyway, so yeah, we've got this anatomically perfect fifth grader here. And we're gonna put the fifth grader into space and see what happens. So, wait, yes? It's actually very similar to scuba diving. Instead of going to space and going to less pressure pushing on you when you scuba dive, you go more pressure, you go deeper, and there's more pressure pushing on you. And indeed, when you come back up from scuba diving, it's a lot like going to space. It actually releases a lot of pressure. Yeah, exactly. It can be dangerous if you get too fast. So, does anybody remember? It's going to be it's like 3 years ago, so now. But there's usually somebody who remembers the name Felix Baumgartner. So does that ring a bell?
I'm kind of familiar with that.
Yeah. Red Bull he did something crazy, and this guy, and Red Bull was his sponsor. Yeah. He did something really stupid. Does anybody have a guess? It has to do with this kind of thing. Yeah.
If you do it, you said you were going to do it.
He went to space. He went to space on a capsule, and it was hung by he didn't go on a rocket. It was on a balloon. So maybe people have heard about this. So he took a weather balloon and put a capsule below it. And the weather balloon is big enough to actually take you to the edge of space, about as high as this thing simulates. Okay. And then he got out, and he jumped off. And he fell to Earth. He fell so fast he actually broke the sound barrier. He went faster than the speed of sound, falling.
Wow.
Eventually slowed down, almost died. Pulled his parachute, landed, and disappeared. I just retired, I guess. Never heard of it. But a couple other people have done it since. Yes? He didn't happily. But how many people would do that, right? I mean, go jump off a cap. That would be so much fun. Yeah, exactly. So the reason I'm bringing this up, though, is if you saw pictures of this, what was he wearing? Was he wearing like a ball cap and a T-shirt up at the edge of space? Yeah. He was wearing an astronaut suit. He needed a special suit to protect him, right? Because he was so high, right? And that's important. That's why you need an astronaut suit, to keep your innards in, right? Well, our little marshmallow person, no such luck. Okay, so we need a volunteer again. Keep your hands down if you've already volunteered. Makes it easier. Yeah. Do you want to volunteer? Okay. Do you want to volunteer? Yeah, come on up. All right. Come on over here. All right, so your job is to be our eyes in the sky, boots on the ground, roving reporter, okay? Perfect. So I'm going to plump this down. We're going to take our little fifth grader to space. And I have to ask again, we have to make this hypothesis. Is the fifth grader going to get smaller when we take it to space? Marshmallow Man. Yeah? Okay? Get smaller. Now remember, we have our balloon to train our intuition. Is the marshmallow man going to stay the same size? Raise your hand. Not going to change size. Okay, nobody thinks that anymore. Okay. What about getting bigger? Is the marshmallow man going to increase in size? Okay. All right. A few more people are thinking that. What do you think? Going to get bigger? All right. Very good. No wrong answer again. And ready? We're going to go do it. Keep the eyes on.
Oh my gosh! Make him explode!
It's interesting, sort of went through a peak. Maybe just sort of hanging out. I know. You're going to get the show. All right, we're going to bring the marshmallow person back down, okay? And I have to ask it, is the marshmallow person going to be smaller than originally? Raise your hand. Is the marshmallow person going to be the same size as original? Go right back to the original. That's what the balloon did, remember? Okay, so Is the marshmallow person going to be stay larger than originally was? Okay, what do you think? Okay, go back to the same size? Okay, all right, let's find out. That's what the balloon is, right? And I'm going to go ahead and unplug it. And let's see what happens.
His mouse is down.
That was not a good situation. Have two faces, right? Happy face, not happy face anymore.
Oh.
Isn't it also a lot colder in space though?
Interesting. It can be. Yeah. If there's nothing there, there's actually no real temperature as far as like material temperatures. It can be very hot, right? When the sun's shining on you, your surface will be hot. So let's talk about what happened here. We did two different experiments, taking two different things in space, and they operated very differently. This one got bigger and then went back to the same size. This one obviously didn't. So how many people have eaten a marshmallow? Yeah? Here's where we part company. How many have eaten half a marshmallow and looked at the other half? Yeah, I've never done that. So, but I've heard that if you look into the marshmallow, what's inside?
Sticky
Like
stuff.
it's sticky stuff. But what's the texture of it? What's the
It's
texture? It's airy, which means it's like what? It's got lots of little tiny
Bubbles.
bubbles. Yeah, it's full of bubbles, which are actually basically little tiny balloons, right? It's full of little balloons, but they're yummy, delicious candy balloons, right? Because if they're rubber balloons, yuck, right? This is actually a very different type of a balloon. We took it to space, and those balloons did exactly the same thing this did. They all got bigger, and we saw that. The Marshmallow Man grew. But then those candy balloons, right, they're not rubber balloons. Eventually, they popped. And the air got sucked out and through the tube and gone. Yeah? So it was actually changing the marshmallow. We were actually taking air out of the balloon, out of the marshmallow. Then we brought it back down to the surface of the Earth, and the air was gone. And so it shrunk up into a little shriveled raisin marshmallow. So this is your opportunity, guys. Run, don't walk to the patent office, because I just gave you an idea for a marshmallow deflation device. Yeah? Sir?